DeFi by Design, where we talk all things blockchain and cryptocurrency while striving to educate, empower, and enrich.
What's going on, guys? Welcome back to DeFi by Design, episode number 105. In alignment with our name, the Rollup, we're here today with Alex, the co-founder of zkSync/Matter Labs. They're building out a really cool ecosystem, a zkRollup that is now live, has some really cool projects and TVL growing there. This is kind of a part of a broader educational initiative that we're pushing forward here at the Rollup, really trying to understand the impact of zk technology. So today's episode, you can expect tons of really interesting takes from Alex about zkRollups, the innovations that this tech enables, what they're building at zkSync, some fun conversations that we had in Paris, as well as some of the impacts that we're trying to make here in the broader DeFi space. So yeah, good morning, Rob. What's up, man? Where are you calling in from? How you doing?
Good morning. Good morning. It's another beautiful day in Florida. Been hopping around a little bit behind this virtual background. I'm in a new spot, so that's exciting. And yeah, we've just been like leveling up consistently, which has been really fun. It's like the market conditions have shaken out like all of the weak minds, which I think is a fun consequence of the recent market conditions. So all that's left is gigabrains. Which is really cool, really interesting. And we have one here today, Alex. Absolutely pleasure to talk and welcome to the Rollup.
It's my pleasure, guys. Thank you for having me.
Cheers, man. So let's dive into it. Like maybe a good place to start is from the beginning, right? So I would be interested to know like what your origin story is. Like where did you come from? Why did you dive into building a protocol, a layer one? Maybe we can touch on the FAT protocol thesis if that's something that you hold near and dear to your heart. And kind of like what is your motivations and why are you building the thing that you're building, zkSync?
To me, blockchains in general are a really interesting intersection of technology, math, and programming, business ideas, and kind of this potential to transform society in ways that can bring more freedom, more equality, more power distribution to the people. And you can imagine this Venn diagram with these three circles intersecting. That's the world of blockchains. And those were really like all three things that brought me in there. From technology, my background is in computer science and software engineering. I have been co-founder of a couple of startups in my past life. It's really interesting what blockchain can do to the to overall the world of value, like how it can extend internet with a layer that brings everything really like that touches value, from finance but also to like tickets and invoices and all these things on the internet in a much more composable way. But what's really the core for me, this idea that blockchain can improve freedom, and this is the mission of zkSync, to advance freedom for the world using this technology. And to me, it's really important because I was born in a very unfree place. I was born in Soviet Union, in Soviet Ukraine. I grew up shortly after the collapse of these like massively centralized state with a lot of institutions collapsing and not being functional. And I have seen the impact on the society. And I realized that the more freedom you have at every level, at the national level, at individual organization, at any kind of group, the better off this group is going to be on average. So like for me, it's all of that. And why blockchain? Why rollups? Why zkSync is a rollup and not a layer one? We have to look at what's the core value proposition of crypto, and to me, it's decentralization, trustlessness. And we have spoken. We recently published a manifesto of values and mission statement for zkSync community, a zkSync project called the zk Credo. And we go in detail, like in a very specific manner, about the properties that we want to see preserved in the blockchain. And so this decentralization trustlessness is something that's really the core job of a layer one. The main purpose of a layer one is to create the most decentralized, the most resilient most inclusive infrastructure for blockchains. And I think Ethereum has done that to the by far better degree than anyone else. And it would be really, really hard to compete with Ethereum on that, because it's not just about technology and about the ability to have like tens or hundreds of thousands of nodes, of validators, of full nodes that just verify the chain. But it's also about the community, and it's about the decentralization of the stakeholding, like with distribution of the Ether token around the world, geographic distribution, distribution of like a mind share of businesses, of individuals around it. So like it would not be possible. But Ethereum has a problem of scalability. It's obvious that the technology that the layer one is using, and it has been obvious to everyone for the past 5 years, and it was obvious to Vitalik, where he came up with Ethereum's rollup centric roadmap. This core technology, since you focus on decentralization above, like you prioritize it above everything else, you can really do other things as good. And this is where rollups come into play. And we can deliver scale, and we can deliver other properties that layer one cannot directly have, such as privacy, for example, with zero knowledge proofs. And rollups are the only technology, the only approach which we have that can scale layer one without destroying its core value proposition. So we have two types of rollups, optimistic and zk. I'm obviously biased because I'm building a zk rollup, but I started building it because I believe that zk is the most magical, the most interesting transformational technology for the coming decade or even more. The properties, the superpowers it gives you, enables in the rollup, are unbelievable, and so like we can talk about them in more depth, but that gives us the ability to reach the holy grail of scaling, which we can define as mass adoption, where anyone in the world can have access to blockchains in a inclusive, easy, accessible, affordable manner, where every transaction is like negligibly cheap, and you can do whatever you want better than you can do in the internet, and easier with greater UX, but most importantly with preserving your sovereignty over your assets, self-custodiality, and full freedom to do what we want. This is why we're here.
Yeah, it's base. If you had to describe zkRollups or zk in a couple sentences for somebody who'd never heard of it, how would you do it?
I can try. It's a so we have to make a step back. Ethereum embraces modular approach to its architecture. You can imagine an architecture, like any kind of monolithic architecture, will suffer from inflexibility in its design. So if you want to build something modular, you don't build a Boeing 737 by making a single drawing of all of its parts, right? You decompose it into subsystems. You say like, okay, we have wings, we have engines, we have avionics, and so on. And you have different teams working on those different subsystems, and then you combine it all together. The Ethereum has chosen the same way. I think it's the wisest way possible to build scalable, fast-growing, fast-developing infrastructure technologically. And rollups add a layer of scaling computation and storage. So what rollups do is, instead of submitting all the transactions on layer one, we bundle transactions together in blocks off-chain, and then we do some pre-processing. We compute the cryptographic commitment to the state, which we get after applying all the transactions in this block, and we only submit one single hash on layer one, which corresponds to this new state, which is like we call it cryptographic commitment. Whenever you change anything, even one bit in this state, this hash will completely change, and it's not possible to fake because it's cryptographically strong, collision resistant, and pre-image resistant hashing. And with this one hash, anyone who can observe this hash on layer one can work with this state, can make the next transition, can withdraw funds, can deposit funds. But the state is actually held off-chain in a much more scalable way. So we derive the settlement properties from Ethereum, the finality from Ethereum, and rollups. Also, unlike other scaling approaches attempted in the past, Rollups share all of the information about this, kind of necessary to reconstruct the state of the new block through the Ethereum network. So we use Ethereum as a data availability network, not as a storage network, but as data availability. So we only use it to make the new state available, inform everyone about what's changes in this block. And so having those two properties, relying on Ethereum for finality, relying on Ethereum for data availability, and also a third property, which is gonna complete this picture, is relying on Ethereum for the validity of the transactions. How do we make sure that this new state which we commit is actually valid, that we followed all the rules of smart contracts, of the signature verification, of everything which is happening in this new state? And this is the magic part which rollups perform. Like, how do you do this verification easier, cheaper, or at least cheaper from the perspective of full nodes on Ethereum than if you do it directly on Ethereum? And to explain that, we can remember that whenever you send a transaction on Ethereum, it will be replayed by all full nodes, because we have this maxim of don't trust, verify. So you have to re-verify every single transaction. And that doesn't scale, because if you have 10 or 1,000 times more users and 1,000 times more nodes, you will have to do 1 million times more work, which is unsustainable. So we call it quadratic complexity of n square, mathematical terms, and this would just quickly grow beyond anything feasible to actually practically implement scalability. So what we do with the rollups is we kind of I will not speak about optimistic rollups now. They do it in a peculiar way, but with zk proofs, with zk rollups, we have one entity compute something called the proof, compute the snark, a proof of computational integrity for this entire block. So one entity makes a little bit more work than everyone else would do individually to just natively compute this, the new state. But then they produce this succinct proof that, you know what, this new state is actually valid, and we completely followed all of the operations, all of the functions that we wanted to execute. And then we send this short proof to Ethereum, and we let it be verified by a smart contract, which is the gatekeeper of this new state. And once this snark, this zero knowledge proofs is verified, only then will the smart contract on Ethereum allow the state transition to happen. So what this means practically is we do much less work, and it scales almost linearly with the number of users. The amount of work, just like if you have 1,000 times more transactions, you will have to do 1,000 times more work, not 1 million times more work. But every single full node, every single validator on Ethereum still practically verifies all of these transactions that happen there, even though they are doing just a fixed amount of operations on chain, and you only pay a fixed price for this verification, which is borderline magic to me. This is why zero knowledge proofs have been called magic moon math, because it's a bit counterintuitive how you can achieve that, but it's actually not as complex, and there are many really nice tutorials meanwhile which go and can give you some intuition on how this works mathematically.
Yeah, and so that enables tons of new innovations on zkSync and for all zkRollups. Talk to us a bit about how that technology enables innovations that may not be possible on other chains.
So we'll start with the sheer scale that will be possible once we reach the full maturity of the zkRollups. To talk about full scale, we can talk separately how we reach this full scale, because it's not trivial and it requires one more step, and we can talk about it speaking about zk stack. But imagine that you can have it, today on Ethereum you can process 20 transactions per second. Imagine you can process hundreds of thousands of transactions per second without losing any of the properties that make Ethereum. What you can do, well, and each of the transactions is really cheap. It's a fraction of a cent to compute it, or maybe 1 cent if it's a really highly secure transaction. You can finally afford to bring real world users to the systems without fearing that you will bring the network to its knees and it will just collapse once you have huge like 1 million people mint an NFT, or like a lot of people on board to DeFi and start using it, or like everyone just switches to payments to blockchain, and then you can replace credit cards with blockchain payments, which are much cheaper because you only pay a fixed amount per transaction and not some percentage, which is way beneficial to the merchants and to the consumers. So like just this scale is one thing. The other thing which is possible then with specifically with zkRollups implemented in the right way is privacy. Now, privacy is kind of possible in Ethereum today. We had some protocols that already deployed on Ethereum that supported privacy, like the Adstack protocol or the infamous Tornado Cash, which was banned for political reasons. But like I think those, it will be solved, and we'll find ways to both make regulators happy and also preserve the true privacy for the users. But it was working, right? Like you could like have perfect privacy, mathematically, like perfect obfuscation of all the transactions, of all the, like no one could learn any facts from the transactions on chain. But it was incredibly expensive. You have to pay like hundreds of dollars to interact with Tornado Cash. And even with like something like optimistic rollups, where you have to put all of the data for each transaction on chain, it would be still relatively expensive. zkRollups can allow you to make the privacy transactions as cheap as any normal transfer, because you don't have to publish the data. You only have to verify it recursively, and recursive verification these days is costing close to nothing. Like it's negligible compared to the cost of transaction. So you get scale, you get privacy, and then basically we just fulfill the full potential of blockchains. You can do whatever we're going to build on these technologies at huge scale.
When you mentioned the recursive nature of recreating these transactions, that sounds like a fundamental difference between zkRollups and optimistic rollups. So you also mentioned that the data to recreate these proofs is available on Ethereum. So how do zkRollups achieve this scale, whereas optimistic rollups do not achieve this scale?
This is a great question. So like let me formulate it more precisely. We don't publish the data for reconstructing the proofs or re-verifying the proofs or re-verifying transactions themselves. In fact, the architecture of zkSync specifically, and here we differ from all the other zkEVM projects that are currently in existence. The only other zkRollup that follows this approach is Starknet. We publish the state diffs. So we don't publish any of the inputs of transactions. We only publish the final changes in the state. Like we touch this storage slots, so the new value of the storage slots is X, and we only publish that. So we can discard all of the inputs. You can have a very large input, which can contain a lot of things. Like you can have account abstraction and all the parameters of account abstraction and some like custom signature scheme, which you sign from your mobile phone, which maybe like is large. You can specify some preconditions, post conditions, some security things. All of that will be taken as an input of this transaction, will be processed by the rollup, but it will be discarded. Like you don't have to publish it on chain, because it's not directly going into the state changes. The state changes will be only derived from what you actually accomplish. If you make a trade, make a swap of a token, then you subtract the balance of the first token and you add the balance of the second token, and you only have to post this to final storage updates, maybe like the update of your nodes, right? So by doing this, we get some really, really interesting property. We can now decide whether we want to publish data availability 100% on Ethereum for all accounts, or maybe we want to split our accounts in the valuable ones, like super valuable ones, where you hold a lot of money, maybe like DeFi protocols, maybe users' savings accounts where they hold all like most of their savings. And you can create a different account type, which let's call it like Validium account. We work on an architecture called zk Porter, which implements that. And those accounts can be used for things that are less important. like you still get the full benefits of the validity proofs. So all the transactions touching those accounts are verified by Ethereum. So you cannot fake anything. You cannot violate the rules of smart contracts. But maybe you have Oracle contract there that, like if the data disappears, nothing bad will happen to this account. Or maybe you have some small account which you're only using for testing, or like you just want to play around with the blockchain, you want to create something. Or maybe it's a game where like the state is still like fairly centralized, so you just want users to have like rules of the games enforced, but not like the tokens or the NFTs there are not as critical. So then you could use this Validium or zk Porter type of account for this, which has slightly less security. Like the only difference in security is that for this Validium accounts, you don't have 100% of security of data availability guarantees from Ethereum. So potentially data could become unavailable if the validators are malicious, right? But for those use cases, it does not matter as much. And these transactions can be way cheaper. Like today, on all rollups, if you look at the prices, the fees for transactions are in the range of like several dozen cents, right? Like from 30 cents to $1 to like a few dollars. They fluctuate with Ethereum gas price. The higher the gas price, the more you pay. Why they fluctuate? Why are they bound to Ethereum gas price? Because with the bulk of these costs is going to Ethereum for data availability. So all rollups on Ethereum share the same bottleneck, the same bandwidth of data availability available for the rollups. And even if we extend it, and there are plans to extend it with EAP 4844 to make this space larger, it's still going to be limited. And we'll always hit this limit, and the price will always go up. So if we want to build a system that can scale limitlessly, just like the internet, where you can, like, you're not inherently limited by a single amount of servers, right? You can always add more servers, more data links, more connectivity, and you can grow, like accommodate any number of users, of transactions, of data volume. We want the same thing in the world of blockchains, and specifically with Ethereum. And so the way to achieve that would be to have many different rollups, many different systems deployed in a way where users can select where they want to host the data for their specific account. And so coming back to the difference between zk and optimistic rollups, in the world of zk, we can build those systems like in the zkSync ecosystem, we call them hyperchains. And we can make them seamlessly connected to each other, regardless of where the data availability is stored. Like for both Rollup and zk Porter accounts on any of these hyperchains can seamlessly interact fully trustlessly with minimal costs, without like with the same costs as the transaction on your hyperchain, with any other account on any other hyperchain. So you can think of it as the email system where I have my email like alex@metalabs. You have Robbie at rollup.co. You have Andy at Gmail. I can send email from any address on any of those domains to any address on any other domain in exactly one click. It doesn't cost me more. I don't have to do more work. If it costed some money, like I would just pay the same amount as sending it within MetaLabs, within Gmail, and so on. This is what we can build with the zkRollups. So this is the biggest transformation of zkRollups compared to the optimistic rollups. With optimistic rollups, you can have a multi-rollup ecosystem. It's actually beneficial because in optimistic rollups, all the users of a rollup are expected to revalidate the transactions. If you're not doing that, you still rely on someone else for security. It's not how it's intended to scale. Like if you use rollups for scaling, someone has to do the work, and like a lot of users have to do the work, and at least one of them has to be honest for optimistic rollups, right? So it has some merit, but the interoperability between those independent sovereign rollups will take like 6 days or 7 days for trustless messages to arrive there, and you cannot extend the space for the address space, the account space, with this off-chain extension, which would then seamlessly be interoperable with all the other rollups. It's just like fundamental limitation of the architecture. And this is why it's obvious to me that long term we will only have zk rollups. Like optimistic rollups are really, really important now because they launched earlier. They provided relief to Ethereum. They saved Ethereum from like users migrating to other like Ethereum killers, other chains for being like, because it would be way too expensive to transact on Ethereum. So it's great that they're there, but they will eventually have to migrate and like embrace the zk technology or just disappear.
Do you think they will eventually have to migrate to the same sort of architecture where you split up like larger accounts and smaller accounts into Validium accounts?
I think so.
You think
I think
okay.
I don't know if that's feasible, because that's a lot of work. If you don't put this architecture in from the beginning, it's going to be really hard to migrate. So like, but you can always migrate the users from one rollup to another, right? So we'll see like how this will work. But like, we have this architecture from the beginning, and it was not trivial to build to make it there from the beginning.
Yeah, I think on this point of interoperability between these hyperchains within the kind of the zkSync or the zk stack, you get to a question about interoperability with shared liquidity and kind of how they interoperate with each other. And there's two concepts there that I think our audience would like to hear about, which is understanding what shared sequencers are and understanding shared provers and the pros and cons of kind of the centralization of a prover, you know, or of a sequencer in the current ecosystem. So if you could start at the bare bones level of what sequencers and provers are, and then kind of walk us through the vision that you have for this interoperability inside of the zk stack with shared sequencers and shared provers. So you kind of have these chains that are different, and it could have, you know, could be L3s, L4s to the nth power, but can all kind of share liquidity and share the same experience within the zk stack.
Absolutely. So like, let's start with the basics. A sequencer is simply any entity or any like mechanism that bundles transactions together for a rollup and then submits these big batches on layer one. It can be a centralized entity, like just a one single server. It can also be a decentralized thing with a consensus running off-chain, which collects transactions across multiple validators, and then they use BFT kind of style consensus to decide what's the state of this block is going to be. So all the rollups today basically use these centralized sequencers because they were easier to implement, and most rollups have plans to transition to decentralized ones. At zkSync, we're working on the decentralization of the sequencer for a long time, and we will soon publish the first results on, like, we will have it on testnet for everyone to try. Like it's core to our mission. It's core to zk Credo. We will not stay centralized sequencer for a long time. So that's the sequencer. Now, zkRollups, after you publish or like after you produce, they bundle the transactions together in this block. Someone needs to generate the zero knowledge proof for this block, which is a quite computationally intense operation. Again, like, this is the job of the prover. The prover proves that the block is valid. It can be a centralized prover running in the cloud on AWS or Google or Baidu or wherever. It could run on your personal hardware, on your GPUs, or it can be a decentralized one where the work is distributed to multiple entities, and then you collect the result, and you recursively combine the proofs until you get one final proof of the entire block. Again, we start with this more centralized version of the prover, and we will transition towards more decentralized version. And it's very obvious to us that eventually everything has to be decentralized. This is why the new proof system, the new implementation of the proof system we recently announced, called Bujam, is optimized for decentralized proving. We have a GPU implementation that can work with consumer-grade GPU hardware, which requires only 16 gigabytes of RAM. In the worst case, we can even tune it down to 6 gigabytes. So like it can run on basically any GPU on any like gaming machine or MacBook or anywhere in the GPU mining rigs that were previously used for mining Ethereum and so on. So this is the prover. Now, the question was about shared sequencer.
The shared liquidator, yeah, the shared sequencer and shared prover to facilitate the interoperability that you speak of.
Yes. So let's start with shared liquidity. in order to have shared liquidity between rollups, you need to design them in a certain way so that you have this trustless messaging passing from each of them to each other, and you need to manage the token storage, the token treasury of the rollup in a certain way. Like if you split the treasuries between two rollups, let's say if you have like completely two separate rollups, like zkSync and I don't know, like something else, some other zk rollup or optimistic rollup on Ethereum, we will store the assets, the native assets of coming from Ethereum in two separate contracts on layer one. One will have all the assets locked for zkSync, the other have all the assets locked for this other rollup. And so we cannot talk, like there is no way to have shared liquidity. In order to bridge something from one rollup to the other, we'll have to pass a message. And even if the other rollup trusts the message and says like, oh, I trust zkSync's implementation and I trust its governance and upgradability protocol to be perfect, to be not compromised, they still cannot do much because the money is still locked in the zkSync base contract. So we'll somehow need to get this ETH or other tokens over to the other rollup. For some tokens, it's easier to do, like for USDC, for example, because it's managed centrally. They can easily centrally mint and burn protocol like assets on different chains. This will work. But for native assets are hugely important. Like Ether itself is the most critical asset in the Ethereum ecosystem, and you cannot. It has to remain native. It's the whole point of DeFi is that Ether is used as native collateral, which does not depend on any centralized entities. And to move Ether, we would have to make a transaction on layer one, and this will create a bottleneck of scalability, and there is no shared liquidity. So the shared liquidity can only be within ecosystems. Like on zkSync, there will be a network of hyperchains driven by zk stack, within which the shared liquidity is present. Maybe other rollups will develop it. So, but we'll have this kind of closed ecosystems, unless at some point we all agree on the standard for shared bridge and we kind of coordinate and maybe enshrine it in Ethereum itself, and then we share it all across all the ecosystem, which maybe potentially a future which we could reach. But like I'm not sure that like this is certainly not a near future. This is like years away from until like we could get to something like this, because we need all the components of the system to ossify by that time, and we're doing a lot of development, like really active, like really high frequency of innovation, of cycles of upgrades and so on. So like not for soon. And I mentioned the zk stack a couple of times, so I want to take a second to explain what it is. The zk stack is simply the open source framework based on the code of zkSync era, the first rollup we deployed with like the first zk EVM on Ethereum, essentially, that anyone can use to build their own hyperchain. So if you want to deploy your own rollup, you can just take zk stack and deploy it. We currently are preparing it for like we're bringing it in the form where anyone can do it on their own. For now, like it might be a bit complicated. Like there's some things in like some parts of the code are not as easy to work with independently, but we're running a pilot project with a number of we're running pilots with a number of projects to experiment with zk stack and bring it into full production form within a couple of weeks from now. So if the audience is interested, just reach out to us. We have contact on zkSync.io and we'll talk to our BD team and we can make it work. But in the short term, it will be easy for anyone to just deploy it in one click. And the code is open source from day one, fully permissionless under MIT Apache license, so anyone can use the code. And everything we will ever do is going to be full open source under these permissive licenses. Now, shared sequencers. You asked about shared sequencers. In the ecosystem of hyperchains, the liquidity can be shared seamlessly, and the messages are trustless and relatively fast, but they're still asynchronous, which means like one rollup can send a message or some value or some message with value attached to it, to another hyperchain. And it will relatively quickly, like within seconds or minutes, depending on configuration, it will reach the other chain destination. Will be the transaction will happen there. You can even program it to send some value back. So you, as the user of like Era chain, could, for example, trade on a Uniswap specific chain and then just do one click, send value, and then it comes back with a different token. You can imagine this kind of UX. But it's asynchronous. So you cannot do things like flash loans. Flash loans must complete within one single transaction atomically. Either all of the steps of the transactions complete successfully, or all of them fail, but you don't have the first part executed and the second part failing. And the only thing to do things like this would be shared sequencers. So they would enable like seamless composability across all the chains, like without any asynchronicity. But I don't think that this is for everyone, because with shared sequencers, you are giving up a lot of sovereignty. So like you essentially, you give up your right to decide on your own how you're going to be handling MEV, how you're going to be handling transaction ordering, what you're going to be optimizing your protocol for, how you like, what's your fee model, how you're going to structure it, maybe what token you use to pay the fees, maybe what token you use to like manage the sequencer. You don't have control of all of that. You just go into the sequencing layer and you just ask them to do it for you. So I think that this might be valuable for some protocols, especially for smaller startups that want to borrow this credible neutrality and decentralization from something more established and battle tested. And I know of a couple of really smart teams working on shared sequencing, like really strong people. Like I'm sure they will come up with good results fast. But I think for some rollups, sovereignty is paramount. Like the ability to launch their own token for whatever reasons, the ability to control MEV flow, or like to just innovate on the MEV and say, you know what, everyone is doing X, but I'm gonna try the approach Y, because like I believe that there should be no extractive MEV, so I'm just gonna time locked encrypt all the transactions. Or on the contrary, I want to extract maximum MEV and send it to my sequencer for the treasure of the protocol. Or maybe like MEV problem does not apply to me at all. I just want a really fast sequencer with instant confirmations from a centralized source, because I'm doing high frequency trading. All of that freedom should be left with the users or with the builders of those protocols. And so I think some of them will use it, some, maybe most, won't.
Got it. So those builders are the users of zkSync, and like zkSync has its own network and its own chain, and there are apps that are deployed on zkSync, and there's also the builders who are building these hyperchains on top of the zk stack. So zkSync era implies the existence of another era, right? Is there like a second era, or like is there a roadmap as far as like how zkSync is on the path toward this hyperchain universe or world?
Oh yeah, absolutely. So zkSync era is just the name of this first base chain, the first hyperchain that we put in existence. And it's a generic purpose chain. So like for most use cases, you probably don't need to launch your own rollup. You don't need to launch your own hyperchain. You just want to deploy on a broadly decentralized, credibly neutral, trustless platform which enables you to reach high scale. That is Era. Like if you just want to deploy a DeFi protocol or NFT protocol or some interesting identity application, you can just do it on Era. You don't have to wait for the hyperchains to arrive, or you don't have to build your own. Era is experiencing explosive growth. Like the numbers we see, like it's the most popular L2 on Ethereum for the past couple of months. With like on many days we exceed Ethereum's transaction volume. We have I think the largest number of active daily users. We are third largest L2 by TVL, and TVL is growing. we have like basically daily, like a number of protocols are deploying some interesting things on Era, and we have not even yet unlocked all the features that make that give you the full potentially full superpowers of Era. This is coming in the next wave of releases that will happen over the next couple of months. So there are some things though that make Era distinct and unique, like for example, native account abstraction that is not currently present in any other protocols. You can use EAP 4337 on Ethereum and other rollups, but that does not work natively with MetaMask, for example. You cannot do gasless transactions for MetaMask users. You cannot let MetaMask users to pay for fees in different tokens and so on. You can do this on Era, so it enables some really magic UX for a bunch of application use cases, such as NFTs or like wallet abstraction, smart wallets, and so on. So, but yeah, like Era will be just growing on its own. Hyperchains are there for use cases that really require a separate chain. Like maybe you have a special community that wants to have its own chain for whatever reason, because this community is coalescing around that. Or maybe you have a special application that will benefit from an application-specific rollup or an application-specific Validium. Maybe you are an enterprise or you're a bank and you are building. You need privacy out of the box from the beginning, and so you would opt in for Validium, but you still want credible neutrality from Ethereum and trustlessness from Ethereum. You can do all of that with Hyperchains.
And I think you started to drive home the point of the question that was not fully formed in my mind when I asked it. Like we saw some L1s, especially in 2020. There was a lot of like layer ones that were created, and ultimately a lot of those protocols that were deployed on layer ones, they were almost carbon copies of other protocols that were deployed on other chains, and we had this essentially like this even EVM like side chains. There was almost like this competition between side chains, whereas a lot of them could have maybe just been on the same chain and just been different apps on that chain. So Andy and I have talked about this at length, where it almost seems like we're repeating this part of the cycle, except this time it's L2s instead of side chains. And I'm curious whether or not, and that's part of the reason why I asked the question about like, why should someone deploy on zkSync Era or deploy their own hyperchain from the ZK stack? Is it, and you started to answer that question as well. So are we on the same path that we were on in 2020 when there was so many side chains and there was starting to become competition? Is that necessarily a bad thing to recreate that competition with L2s? And do you think, or why is it beneficial for someone to launch their own chain from a ZK stack or even an OP stack? Why should someone take that leap and ultimately deploy their own chain instead of simply take the app and the protocol and deploy that on top of existing infrastructure on an existing chain?
So yeah, I started to answer this question on the business dynamics. It's inevitable. Like it has happened in the beginning of the internet with like social networks, where everyone will launch a social network for its own community. With other kind of platforms, I think this is an important discovery phase where there will be this innovation and it will crystallize what works, what doesn't work. And for some cases, it really makes sense. For some other cases, it doesn't. I think the key where it makes more sense is the actual innovation. When you do something different, like if you just launch the exact same chain, it will probably not be successful, because like if you just launch the exact same general purpose chain as the existing ecosystems, you will be competing against the already trending networks with momentum.
And the EVMs, right? That's kind of what happened with EVM networks.
With EVM, I don't think anything else but EVM currently like makes sense for smart contracts, because we have this really powerful ecosystem of tooling, of the code, of libraries around EVM. So like it will be hard, right? If you're building something completely different. This is what alternative L1s have discovered, and this is what alternative rollups are currently discovering that are not based on EVM. But that's put aside. If you're an EVM, you can still innovate in interesting ways. You can say maybe you are building something that takes privacy to the new level, and specifically on this chain. Or maybe you're doing something interesting with a sequencer or MEV layer. But you have to differentiate somehow. You have to do something differently. If you're doing something differently, I think it makes sense. So and the best way for you to do something differently is like not to reinvent the wheel, but take something like take a good base, something like zk Stack that is battle tested, we invested millions of dollars in security and security audits, in security contests. We have like big dedicated teams working on efficiency, on decentralization, on all aspects of security. Like we're very paranoid. We're very deeply having the security mindset embedded in all in all stages of the design and implementation and testing and rollout process. So like, why replicate all of that if you can take that as a modular stack, as a framework, and then you can just tweak on specific things. Like you just replace the sequencer, or you just make the sequencer better in some ways, or you just like change the data availability mode and you say like, I'm going to keep it to myself, and then I'm going to do privacy application around like whatever I need there, right? This is how I would see it.
Thanks for that. Yeah, as you kind of wrap up here in the final minutes, I wish we had another hour, but when you're done scaling the world and implementing zk technology, from everything from finance to social media to hyperchains, gaming, derivatives, all types of app applications, what's a passion project or a cool use case that you would like to see built out, or that you'd be interested in building out yourself, that is available because of this technology?
It's really like I cannot talk about specific applications because we have a very sacred culture of credible neutrality. I don't want we're never going to make kings and like prefer ones over the others. We want zkSync to be completely even playing field where everyone can do things better, and like it doesn't matter if you're a big existing project or a newcomer, you always have a chance to play it even. I will talk about generic concepts that I really like, that I don't see being embraced to its full. And I think this is a huge potential if someone is going to be doing that. And obviously, if someone is first and just build something new from scratch, we will be endorsing them. We will help this project. We will like spread the word. We'll push the idea that look, here's a new use case. Here's a new approach. Take a look at that. What I really want to see built more is the applications leveraging all the superpowers of native account abstraction. So like you can think of building wallets or just like protocols that allow you to, like, for example, replace a bank, which offer you all the functions that you have in a bank, where you can create sub accounts. You can create like a family account, and then you give it to your kids or spouse or whoever with some spending limits or daily spending limits. You can create session keys where like you kind of like on this browser you can do certain things in your game, in your like NFT project, but like you don't have to log in every time. You only send the message once, and then the session key is stored in the browser, and you do everything like Web 2-way, like really easily with just one click, but you cannot do a lot of harm. Things like this.
And thanks for that. I appreciate your time. I feel like this was extremely educational. Learned quite a bit about just zk and what you're building at zkSync. So thank you for this. And yeah, man, it was a pleasure. We look forward to fulfilling our role in the space and just kind of educating as much as we can. So yeah, it was a pleasure.
It was really cool. Thank you guys for great questions. I really enjoyed it.
Thank you, Alex. This is fun.